The main purpose of today's discussion is to understand how velocity triangle of turbomachinery is drawn. This will be explained in a much simpler way. So let's start the discussion. Discussion point is relative velocity of turbomachinery, centrifugal compressor relative velocity. Centrifugal compressor velocity triangle and pressure radial turbine velocity triangle. So we'll discuss these 3 points. Uh, let's start the reference point of view. The earth is considered stationary, but earth is not stationary. It is spinning around its axis as well as it is moving around the sun. Its diameter is 12,742 km. It spins one revolution in 24 hours. So tip speed of the earth is pi into d into n, which is 2 pi into 12,740 into 1 by 12, which is equal to 1667 km per hour approximate. That means it is spinning double the speed of commercial aeroplane. The earth is spinning from west to east direction. A view from the North Pole, it is turning in counterclockwise direction. You see, this is earth. It is spinning at the speed of 1607 km per hour. Tip speed of the earth. Relative velocity. So case 1, two trains are running at the same speed of 70 km per hour on the earth in the same direction from west to east. No, it's wrong. Not two trains. This is not two train, only one train. Train is running at the speed of 70 km per hour on the earth in the same direction from west to east. If you view from the space, you will see that the earth is moving at 1670 km per hour as well as 70 km speed of the train in the same direction. So if you observe from the space, you will see this is earth speed and this is train speed. So if you add up, it comes at 1703 km is the relative speed the observer can see from the space. Case 2, two trains are running with the same speed of 70 km per hour in the same direction from west to east. Observer on train A, in this case, observer will not see any relative velocity between the two trains because train A has observer on board and B is another train. The speed are same, so there is no relative motion, and so observer can not see any relative velocity. So relative velocity for this observer is 0. Case 3, if train is running with a speed of 50 km per hour and another train B at the speed of 70 km in the same 70 km per hour in the same direction from west to east, if you board on train A, you will see the train B is running with a speed of 20 km in the same kilometer per hour in the same direction. Observer can see the relative speed of train B with respect to observer, that is train A. So here is observer on train A, which is speed is 50 km, another train which is 70 km on the same direction. So there is a relative velocity of 20 km in the direction of same direction, that is from west to east. Case 4, if train is running with a speed of 70 km per hour, another train B at the speed of 50 km per hour in the same direction from west to east. If you board on train A, you will see that the train B is running with a speed of 20 km per hour in the opposite direction, that is east to west. Observer can see the relative speed of train B with respect to observer, that is train A. So you can see train B is moving in the opposite direction of 20 km. Case number 5. If train A is running with a speed of 70 km per hour from west to east and another train train B at the speed of 70 km per hour in opposite direction from east to west, if you board on train A, you will see that train B is running with a speed of 140 km per hour from east to west. Observer can see the relative speed of train B with respect to observer, that is train A. So relative velocity will be 140 km per hour. Now centrifugal compressor inlet velocity triangle. How we can build this velocity triangle based on the train example. So case A, if train A on which you are board is running with a speed of 70 km per hour from west to east, a person on the earth throws a stone at the speed of 20 km per hour perpendicular to the direction of train. So here is the earth, a person has thrown a stone of 20 km perpendicular to the train, observer is on train A and it is moving 70 km. So how this will be? So the stone is 20 km perpendicular to train. If the train has no speed, it will hit directly. But train has a speed of 70 km, so there is a relative velocity of a stone with respect to train, and which is this, and it will strike to train at this angle. So this is the velocity angle. The stone speed, train speed, and this is the relative velocity. Now, if train is replaced by the tip speed of the impeller or wheel of centrifugal compressor and a stone is replaced by the gas velocity to the impeller, please note that only axial inlet flow of the gas is considered, that is IGB angle is not considered. So how we can write? V1 is the inlet relative velocity, U1 is inlet tip velocity, C1 is the inlet absolute velocity, CW is the inlet whirl velocity which is 0, and CA is the inlet axial velocity. So we have C1 which is equal to CA1, U1 is the speed of train, or that is now a speed of inlet speed of tip speed of wheel, and V1 is the relative velocity. So this is the angle normally taken for inlet angle of impeller. Now case 2, centrifugal compressor outlet velocity triangle. If train on which a person is on board, this train is running at the speed of 70 km per hour from west to east, throws a stone at angle shown below at the speed of 20 km per hour. A stone has thrown at certain angle, 20 km per hour. You on the earth and observe the event. You are on the earth and see the event. That means a stone is thrown at 20 km, and because of the train speed it is moving like this. This is train speed, so absolute velocity will be like this. So if train is replaced by the tip speed of impeller or wheel of centrifugal compressor and the stone is replaced by the gas velocity from the impeller, please note that slip is neglected for this case for understanding purpose. So V2 is outlet velocity triangle, U2 is outlet tip velocity, C2 is outlet absolute velocity, CWT is outlet whirl velocity, and CA2 is outlet axial velocity. So how this can be written? V2 is a stone relative velocity and U2 is a total speed of the tip velocity, outlet tip velocity. So C2 is the outlet absolute velocity, and it has now two components. One is CA2 which is axial velocity, and CW2 which is a whirl component of velocity. So Euler head can be written as U2 into CW2 minus U1 into CW1 for compressor. The process radial turbine inlet velocity triangle. Case 1, if train on which you are on board is running at the speed of 70 km from west to east, a person on the earth throws a stone at angle shown below at the speed of 100 km per hour. So observer on the train, which is train is moving 70 km per hour and the stone is thrown at 100 km per hour at certain angle. So you can draw the triangle. This is the train speed, this is the stone, this speed, and if you connect this is the relative velocity of a stone at which it strikes the train. Okay. So if train is replaced by the tip speed of the impeller or wheel of the process radial turbine, the stone is replaced by the gas velocity to the impeller or wheel. So V1 is inlet relative velocity, U1 is inlet tip velocity, C1 is inlet absolute velocity, Cw is inlet whirl velocity, and Ca1 is equal to inlet axial velocity. So how this can be written? C1 is the absolute velocity, U1 is the inlet velocity, inlet tip velocity, as V1 is the inlet relative velocity, and C1 has two components. One is axial component Ca1, and this is the whirl component Cw1. Case 2. Process radial turbine outlet velocity triangle. If train on which a person is on board is running with a running speed of 70 km per hour from west to east, throws a stone at the speed of 50 km per hour at shown below. You are at the earth and observe the event. So you are saying train is moving this and stone is from backside at 50 km per hour. So you can write stone relative velocity, this is train velocity, and this is the absolute velocity. So if train is replaced by the tip speed of impeller or wheel of the process radial turbine, and stone is replaced by the gas velocity from the impeller. So U2 is outlet relative velocity, V2 V2 is the outlet relative velocity, U2 is outlet tip velocity, C2 is outlet absolute velocity, Cw2 is outlet whirl velocity, Ca2 is outlet axial velocity. So we can write V2 is relative velocity and U2 is the outlet tip velocity. So C2 is the absolute velocity, and C2 has two components. One is axial, which is Ca2, and another is a whirl component, which is Cw2. So Euler equation can be written U1 into CW, U1 into Cw1 minus C2 into Cw2. So thank you. With this, I have finished my today's discussion. Hope you will like this. If it is so, please subscribe it, like it, share it. See you in the next session. Till then, bye bye. Thank you.